Hi folks, and welcome to another session of Science with Mrs. Chambers. Today we're looking at some forces work. This forces work thinks about how the shape of an object affects the water resistance as it falls through water. What I've got for this experiment is a vase full of water, not completely full because if I put my hands into it I don't want it to spill over the top, but I'll put it in a baking tray just in case it does. The second part of the experiment, using the same equipment pretty much, is using half of a used envelope to make this boat, and I've got some little Lego blocks, and we'll do a bit of investigating with density with that one. All right, so same apparatus, two different experiments to try. So the first one, I've got some blobs of Play-Doh here. Play-Doh gets quite soggy in water, so try and make yourself a few different shapes. I've got my scale from the kitchen here, so I'm going to make sure that my blobs are about the same mass, because if they're different masses, it's not a very fair test. So mine are about 3 grams each. All right, so that's mine. Now what we're going to do is we're going to time how long it takes for the blob of Play-Doh to fall to the bottom. To make sure that our results are actually repeatable, we can do it 3 times for each shape. If you haven't got a timer, then if you've got a clock that's got a second hand, you can use that. You can find online timers, or you can just count. Okay, ready? So we go, ready to drop. 1, 2, like 1.5. Okay, so I'll get that one out. Try it again. Ready? 1, 2. Yeah, okay, about the same. So I couldn't even quite get to 2 with that one. This time I'm going to squish my blob of Play-Doh. I'm going to see if that has any effect. So what I'm doing by squishing it, I've still got the same mass. There's still the same amount of stuff there. It's just that I squished it into a different shape. So I've made a flat disc. Now, as I change the shape there, more of the surface of the Play-Doh is in contact with the water, which should increase the force of the water against my disc. 1, 2, 3. Yeah, okay. All right, so my disc took longer to fall because with my flat disc, there's more resistance against my flat disc than there was against my ball. 1, 2, 3. Yeah, nearly 3. Okay, so have a play about with that one. You can make all sorts of different shapes. As I say, Play-Doh does get quite squishy. Plasticine is possibly better if you have it at home. This is all I've got in the cupboard, so that's why I'm using that today. Second experiment for you to try is thinking about density. Now I've made myself a little boat. If you've got a little tin foil cake tin, one of those things that you get off of cakes in the supermarket, you could use that. I'm using half an envelope because it's what I've got. This is my boat and it floats on the water. So whenever something is floating like this, the force downwards is the same as the force upwards. That force upwards in water is called upthrust, and it's gravity that is pulling our boat down. Now, because it's paper, it's not going to survive brilliantly well, but I'm going to see how many Lego blocks I can balance on there before it sinks. I've got 1, 2, 3, 4. Oh, I think it's going. Yeah, it's going. Okay, so 4 Lego blocks overcame the upthrust force, and my little white boat sank into the water. Oh dear. Now, what can I do with this? Well, obviously you can try it several times. You can't try it several times with the same paper boat because it gets wet and soggy and it won't float so well if it's wet and soggy. So got the other half of the envelope here. Now what I'm going to do is see if I can get it to take more Lego bricks, and I'm going to do that by changing the water. I'm going to dissolve some sugar into the water. Now you could work out how many spoonfuls of sugar or salt you could add to the water to make it stay afloat with the same number of Lego bricks. So you could try it multiple times. I'm just going to do it once for demonstration purposes here. So here's my other half of the envelope into a little paper boat, exactly the same as the first, pretty much. Okay, so here's my Lego boat. I've added some sugar in there. So 1, 2, 3, 4. It's not sinking yet. 5, 6, 7, 8. Doing pretty well actually. 9, 10. You can see that my boat is the same. And I've added more Lego bricks and it is still staying afloat. So what I've done by adding the salt there, I've made the liquid part more dense, so the upward force is greater and it is able to balance a greater force from above. So there you go. You have a go at that at home and enjoy. Bye for now.